Now we often look at relations that are defined by graphs. What does the graph of the inverse of such a relation look like? Suppose we have the relation graphed in red. Looking at this graph, I can see pretty plainly some of the points on the relation R. Right, we have 5, 3. We have 0, 2. We have -3, 1. We have -4, 0. We have -3, -1. We have 0, -2. And we have 5, -3. Just reading off points that I see on my graph. If we want to graph R inverse, then we should have the point 3, 5 on our graph, just reversing the x and y. 2, 0, 1, -3, 0, -4, -1, -3, -2, 0, -3, 5. Let's try plotting those points. So 3, 5, 2, 0, 1, -3, 0, -4, -1, -3, -2, 0, and -3, 5. It looks like these are forming the same shape, just with the x and the y swapped. I'm looking at the way this is transformed. Look at the dashed purple line. If I picked the red graph up and flipped it across the dashed purple line, what would happen? I think I'd get the green line, don't you? Is that always going to happen? I think that's always going to happen when I take any point and switch its x and y coordinates. What is that dashed purple line? It looks like it has a slope of 1, right? Over 1, up 1, over 1, up 1. And it crosses the y-axis at 0. This is the line y equals x. To obtain the graph of an inverse, we take the graph of the relation we start with and reflect it across this line y equals x. And we do that with the help of some ordered pairs with their coordinates reversed. I'm going to have you try an example. Let S be the relation graphed in red. Sketch the graph of S inverse. Pause the video and try it now. If you get stuck, I'll give you a hint when you play the video again. Okay, my hint is that a list of points on the graph of S might include -4, -4, -3, 1, -2, 2, 0, 0, 2, -2, 3, -1, and 4, 4. And to get points on S inverse, just take the coordinates of these points and reverse them. If you haven't already sketched the graph, pause the video again and try with this hint. So the points on S inverse, -4, -4, nothing happens when we switch those. 1, -3, 2, -2, 0, 0, -2, 2, -1, 3, and 4, 4. It looks like we're going to have several points that are on both graphs, doesn't it? So -4, -4, 1, -3, 2, -2, 0, 0, -2, 2, -1, 3, and 4, 4. That gives us some guidance. And because we know we need to reflect, we know our curve is going to come around like this. So we sketch the curve, and we get an S-inverse curve that looks something like this.